This video discusses the proofs of the trig identities for the summation of two angles A plus B. Under this section, we will see how to prove the trig identities for sine A plus B, cosine A plus B, and tangent A plus B. We will see how to derive the identities for sine A plus B, cosine A plus B, and tangent A plus B. For the derivations of the identities, we are going to need a construction. For the construction, for simplicity, I'm going to assume that A is an acute angle, B is also an acute angle, and also A plus B is an acute angle. For example, A could be like 30 degrees, B could be like 40 degrees. So A plus B is equal to 70 degrees, which means all three are acute angles. Acute angles means the angles found in the first quadrant, or in other words, angles between 0 degrees and 90 degrees. But please note that angles A, B, and also A plus B do not have to be within the first quadrant. They can be technically any size angle, and these trig identities are going to be universally valid. However, for the simplicity of our discussion, I'm going to assume A, B, and also A plus B, all of these angles to be acute angles. Let's go ahead and draw these angles. A and B, I'm going to draw them subject to a certain point. I'm going to start drawing those angles right here. I'm going to assume that this point right here is a point O. And then from that point O, I'm going to show the first angle, angle A. Let's assume that this is our angle A. Let me label that angle, angle A. Now I need to show the angle B. Angle B will also be drawn from this same point O, and I will draw it on top of A. So the angle B is what I have right here. I need to look at sine A plus B. When I say A plus B, I'm talking about this complete angle. For the sine A plus B, I will need a point somewhere here, and from that point, I'm going to draw a perpendicular line like this. So let me label those 2 points. Right here, this point, I'm going to label this point as point P. The base right here, I'm going to label that as point Q. You can see that the angle right here is 90 degrees. I'm going to draw another perpendicular line from P until this straight line. So let me label this point as point R. This angle is 90 degrees. Once again, I'm going to draw another perpendicular line, this time from R. This is that perpendicular line. Let me label this point as point S. This angle is 90 degrees. Our construction is not yet complete. I need to draw one more perpendicular line. That perpendicular line is going to be drawn from point R onto this vertical line. Let me draw that line like this. We will label this point as point T. The angle right here is also 90 degrees. Now our construction is complete. I'm going to write down an equation for sine A plus B. You can see that A plus B is the complete shaded angle at O. And if I look at this large triangle, it's a right triangle, and using that right triangle, and by using the definition of sine theta as opposite over hypotenuse, I can write sine A plus B to be equal to, the opposite is PQ. So it should be PQ divided by, the hypotenuse is OP, PQ divided by OP. PQ can be seen as equal to PT plus TQ. Therefore, I'm going to split that numerator into 2 pieces, and that PQ, I'm going to write this as PT plus TQ. All of that should be divided by OP. Now I'm going to replace this TQ with something else. TQ is the length right here. What can you say about the lengths TQ and RS? They must be equal to one another because TQ, QS, SR, RT form a rectangle. Because you can see that TQ and RS are parallel lines, and also TR and QS are parallel lines. In addition to that, these angles are all 90 degrees. So is the angle right here and also the angle right here. That means TQSR is a rectangle. Therefore, TQ and RS are equal in lengths. So what I'm going to do is I'm going to replace this TQ right here by RS. Now I have sine A plus B equals PT plus RS over OP, which I will write as two fractions, PT over OP plus RS over OP. Now I'm going to pay attention on each of these fractions, PT over OP and RS over OP respectively. When I look at PT over OP, PT is right here, OP is right here. PT over OP doesn't make much sense. I cannot write down any trig ratio for PT over OP. However, if I combine PR in between those two ratios, then I should be able to write down some trig ratios. So with PO and PT, I'm going to put PR in the middle. PT over OP, I'm going to write slightly differently. I have PT on the numerator and OP on the denominator. I will leave them as they are, but in addition to that, I'm going to write down PR. One PR will be written on the denominator, the other PR will be written on the numerator. So I didn't change the question given because you can see that PR and PR can be considered dividing out. In that case, I simply have PT over OP. That is that first fraction. And then I will do something similar for the second fraction. So the second fraction is RS over OP. If I look at RS and OP, RS is right here and OP is right here. Once again, the ratio between those two lines also will not give me any specific trig ratio. But I can write down some trig ratio if I put OR in the middle. So let me put OR in the middle. This is what I'm going to do. I have RS on top and I have OP in the bottom, and I'm going to put OR in the middle. I will write an OR right here, another OR right here. So I didn't change the question given. I can assume that the OR terms are divided out, and then I have RS over OP remaining, which exactly is what I have right here. So practically I didn't change anything. Now we will see if we can identify these terms. What is PT over PR? PT is right here and PR is right here. We can write down a trig ratio for PT over PR if I know the angle right here. This line is a horizontal line and TR is parallel to that line. If TR and OS are parallel, what can you say about the angle right here? That angle should be equal to the angle right here. Therefore, this angle should be of size A. Since this is 90 degrees, we have this angle right here also to be equal to 90 degrees. If that complete angle is 90 degrees, what can you say about the angle inside right here? Since this complete angle is 90 degrees, I need to subtract the A from that angle. So the angle right here should be equal to 90 minus A. Well, now I can write down PT over PR as sine 90 degrees minus A. However, on the other hand, I can also find the angle right here. What is that angle? We know this is 90 degrees. The angle right here is 90 minus A. Therefore, the angle right here should be equal to A. Now I can identify PT over PR as cosine A. Therefore, let me write down this trig ratio as cosine A. Next task is to identify PR over OP. PR is right here. PR divided by OP. That is very straightforward because we know the angle right here is 90 degrees and PR over OP should be equal to sine B. Therefore, this ratio PR over OP, I'm going to write this as sine B. And then I have this plus sign. Then I need to look at RS over OR. RS is right here. OR is right here. We know This angle right here is 90 degrees. Therefore, RS over OR can be easily identified as sine A. Therefore, let me write down RS over OR as sine A. Then we have one ratio remaining, OR over OP. Where is OR? OR is right here. OR over OP is right here. That ratio can also be quite easily figured because this angle is 90 degrees. OP is going to be the hypotenuse. Therefore, OR over OP can be identified as cosine B. So let me write down OR over OP as cosine B. What we just derived is the identity for sine A plus B. Usually when you write this identity, first you write this term and then you read this term. Let me write down the final version of sine A plus B. Sine A plus B is equal to sine A cosine B plus cosine A sine B. Please remember this identity. It's a very important trig identity. Even though I proved it for the case where A, B, and also A plus B are all acute angles, this identity holds true for all sizes of A and B respectively. Now we will see if we can derive another trig ratio similarly for cosine A plus B. I'm going to need this figure, so I'm going to keep that one and I will erase the rest of this note. Let's see how to write down an equation for cosine A plus B. For cosine A plus B, right here once again, the complete angle is A plus B. For that, if I consider this large triangle OQP, then I can see that this angle is 90 degrees. OP is the hypotenuse and OQ is the adjacent. We know cosine theta is defined as adjacent over hypotenuse. Therefore, cosine A plus B should be equal to OQ over OP. What I'm going to do next is I'm going to write down OQ in a slightly different way. I'm going to identify OQ as OS minus QS. Let me write down OQ as OS minus QS. All of that should be divided by OP. And then I'm going to replace the QS term right here with something else. As we saw earlier, TRSQ is a rectangle. Therefore, the length QS should be equal to the length TR. Therefore, I'm going to replace QS by TR. Then I'm going to write down cosine A plus B as OS minus TR, everything divided by OP. And I'm going to split that into two fractions and write it as OS divided by OP minus TR divided by OP. Let's see what is OS over OP. OS is right here, OP is right here. The ratio between those two lengths doesn't make sense. Therefore, I'm going to put something in the middle. I will put OR in the middle. Then I can write down those ratios using the angles A and B. So when I put OR in the middle, cosine A plus B, the first term right here had OS over OP. That OS is on the numerator and OP is on the denominator. And I'm going to put OR in the middle. So the OR term, I will write one of those OR terms in the bottom, the other OR term on the numerator. You can see if I divide out those two OR terms, what I still have is OS over OP. After that, I have this negative symbol, and then I have TR over OP. TR is right here, OP is right here. Once again, TR over OP doesn't make any sense. Therefore, I'm going to put PR in the middle. When I do so, I can write it down. We have TR on the numerator and we have OP on the denominator. And in the middle, I'm going to put PR. One PR is going to be written in the bottom. The other PR is going to be written on the top. Now we will see what these things mean. First, I have OS over OR. OS is right here. OR is right here. By looking at the triangle, OSR, I can identify OS over OR to be cosine A. Let me write down that as cosine A. Then I have OR over OP. OR is right here, OP is right here. By looking at the right triangle ORP, I can identify OR over OP as cosine B. Therefore, let me write down this second ratio as cosine B. And then I have this minus symbol. The next one is TR over PR. TR is right here. That has to be divided by PR. TR over PR should be identified by using PTR triangle as sine A. Therefore, let me write down this next ratio as sine A. The last term I have is PR over OP. PR is right here and OP is right here. By looking at the right triangle OPR, I can identify PR over OP as sine B. Therefore, let me write down this last term as sine B. So what we just derived is the identity for cosine A plus B. Cosine A plus B trig identity is equal to cosine A cosine B minus sine A sine B. This is also a very important trig identity. Please remember that. So far we have derived two identities. The first identity that we derived was for sine A plus B. We said sine A plus B is equal to sine A cosine B plus cosine A sine B. The second trig identity that we derived was for cosine A plus B. We saw this is equal to cosine A cosine B minus sine A sine B. The next one I need is a trig identity for tangent A plus B. For tangent A plus B, I'm going to use these two derived equations already. I will not need the geometric construction. We know tangent theta is equal to sine theta divided by cosine theta. Therefore, tangent A plus B can be written as sine A plus B divided by cosine A plus B. We saw sine A plus B is equal to sine A cosine B plus cosine A sine B. Therefore, let me write down the numerator as that. That has to be divided by cosine A plus B. We saw cosine A plus B is equal to cosine A cosine B minus sine A sine B. Let me write down the denominator as that. Now what I'm going to do is I'm going to divide each term of this fraction by the term right here, cosine A cosine B. When I do so, what I will have on the numerator? On the numerator, the first term is sine A cosine B. When I divide that by cosine A cosine B, I will have the cosine B term divided out. What's remaining is sine A divided by cosine A, which we know as tangent A. Then I have this plus sign right here, and then I need to divide cosine A sine B term by cosine A cosine B. When I do so, the two cosine A terms will be divided out, and I am left with sine B over cosine B, which I need to identify as tangent B. In the denominator, when I divide out cosine A cosine B by cosine A cosine B itself, it will be just a 1. And then I have this negative symbol right here, minus. Then I need to divide sine A sine B by cosine A cosine B. When I do so, I can identify sine A over cosine A as tangent A, that times sine B over cosine B as tangent B. This is the trig identity for tangent A plus B. Tangent A plus B is equal to tangent A plus tangent B. All of that's divided by 1 minus tangent A tangent B. Now I will also show you a couple of simple examples. Here's your first example. Using the known values of 30 degrees and 45 degrees, let's find sine 75. This is what I'm going to do. I'm going to write down sine 75 degrees as sine 30 plus 45, which means I'm going to identify 30 right here as my angle A and 45 right here as my angle B. We know that sine A plus B is equal to sine A cosine B plus cosine A sine B. Therefore, accordingly, this sine 75 degrees can be now written as sine 30 degrees times cosine 45 degrees plus cosine 30 degrees sine 45 degrees. We know sine 30 is equal to 1/2. Cosine 45 degrees is equal to 1 over square root 2 plus cosine 30 degrees is equal to square root 3 over 2 times sine 45 degrees is equal to 1 over square root 2. The denominator is a common denominator. I don't need to write two different denominators therefore. The denominator is 2 square root 2. From this first term, I have 1 times 1, which is just a 1. And then I have this plus sign. And then I have square root 3 times 1, which I can identify as square root 3. So this is the final answer for sine 75 degrees. I also need you to do a small exercise. This calculated value of sine 75 degrees is called the exact value of sine 75 degrees. If you use your calculator for sine 75 degrees, please make sure that your calculator is in the degrees mode, then you should get a decimal value. You can also calculate the decimal value for this right-hand ratio that we just calculated. If you're going to do it in one shot, please make sure to use parentheses around this numerator term and then divide that by 2 square root 2 and see what you get. That answer should be equal to the approximate decimal answer that's generated by your calculator for sine 75 degrees. That's a small exercise to verify that we have actually obtained the correct answer. Just like that, you can find cosine 75 degrees as well. But I'm not going to do it as an exercise. You can do it yourself. Instead, I will do a slightly different example. Here's your example number 2. Find the exact value of tangent 105 degrees. I will write down tangent 105 degrees as tangent 60 plus 45 degrees. The order doesn't matter. You can write it as 45 degrees plus 60 degrees or the way I wrote it. And then I'm going to identify one of them as angle A and the other one as angle B. We know that tangent A plus B is equal to tangent A plus tangent B. All of that's divided by 1 minus tangent A tangent B. With A equals 60 degrees and B equals 45 degrees, we can write down tangent 105 degrees as, on the numerator, tangent 60 degrees plus tangent 45 degrees. All of that should be divided by 1 minus tangent 60 degrees times tangent 45 degrees. Now we can do some further simplifications of that. We know tangent 60 degrees is equal to square root 3. Tangent 45 degrees is equal to 1. All of that has to be divided by 1 minus tangent 60 degrees is once again equal to square root 3 times tangent 45 is equal to 1. So what we just found was the exact value of tangent 105 degrees. You may use your calculator and simplify this value. Please make sure to use parentheses if you're going to calculate everything in one shot. And see if it's the same value that your calculator provides you if you calculate tangent 105 degrees. If you have any questions, please feel free to let me know. Thank you so much.